Motion extraction in Unity Engine Part 4. Right now on the screen you can see the effect that we have after the previous 3 parts, all of which you can find in the video description. And in this part, which is by the way the final part of the series, I would like to do 3 things. First, I would like to do some final improvements to the effect. Then I would like to do a project overview, going once again through how everything is implemented. And after that I would like to do a showcase of how this effect can be applied. Alright, so final improvements. What do I want to do? There are quite a few things. The first one is adding a gradient support, which was suggested by Just Des. So essentially, instead of having custom sections, which is the solution we have right now, we will just have a Unity gradient which will get baked into a texture and then shoved into the shader to process it. So thank you Just Des for the suggestion, that's exactly what I'm going to do. Then I would like to introduce a fade effect on camera movement. What it means is that the effect will fade out when the camera moves a lot, because right now, as you can see, when there's a lot of movement, everything kind of falls apart. So to avoid that, we'll fade out the effect and just output the regular camera output to the screen. Then after that, I would like to add the effect of pulsing between 2 gradients, which was suggested by Zindranerd. I'm sorry, I'm not quite sure how to pronounce your username, but yes, great suggestion, we will do just that. And then maybe I will do some other minor tweaks, and that's about it. So let's actually start implementing stuff. In our C# script, we start with cleaning up the code by removing all of the section stuff. We no longer need that. Then we define 3 variables. First the main gradient, then the path to the texture that the main gradient will be rendered into, and the gradient resolution. Then we create a new function, generate texture, which accepts a gradient and a path to the final texture. Inside this function we create a texture, set its filter mode to point, we create an array of colors, and then in a for loop we transfer the gradient values into the texture pixels. Then we set those pixels, apply the texture, and write the contents of this texture into a file. And then we also create an additional function which will allow us to run this code from the Unity editor with just a couple of clicks. And with that we are done with our C# part. Let's see how it works. Let's first set our gradient resolution to, let's say, 128. Then for the main gradient, let's do something simple. So let's say we start, and this is our gradient, and the main gradient texture path, main.png. And let's generate textures. Right, so we are getting an error. Yeah, so obviously the folder is not there. So let's create folder, textures, gradients. And let's try again. Okay, and now we refresh, and there it is. Nice. Now we're gonna do some shader programming. So I'm declaring the gradient texture sampler to D and the float that will remap the gradient values to the delta values. I'll show why it's needed later. Now I removed all the logic, the unrolled loop. I removed that, and now I'm just sampling the gradient texture at the right point, and let's see if it works. Right, so it kind of works. One thing that I need to do is I need to change the texture settings, and now it should be much better. Alright, yeah, so as we can see, this is much better. I really like how this is looking, and this setup is much easier than having custom sections. So thanks again to Just Des for suggesting this. Alright, now about that remapping variable. Basically what we're dealing with is most values of delta are very small. If we map the delta values directly onto the gradient, so like this, what happens is that most values will be in this small range of colors. And instead of adjusting our gradient manually to be cramped like this to one side, so instead of doing that, we remap the values of delta. How this remapping works is that we say that delta in those values has the entire range of colors, and everything above that is just the maximum value. So basically what we have had with our sections. So with this, the gradient support is done. Let's move on to the fade on camera movement. Back in our C# script. Oh, and before I forget, let's also call generate textures in apply shader params, so that we don't need to do it manually every time. We can just adjust the gradient and then hit start and it'll generate automatically. Anyway, what we can do now for the alpha fading is we first declare some variables as always. We declare the main camera, then the fade out and fade in speed, and the camera's last rotation and position. We also declare an alpha minimum value. We set the camera's last rotation and position on start, and then in update we check if they changed since the last frame, and based on that we interpolate between the current alpha value and the target alpha value, target being either the minimum or 1. We then add the alpha variable to our shader and multiply the final color by this alpha value or alpha multiplier. And the last thing we do is we set the value of our alpha multiplier through the C# script. And with that, the fade effect is done. As you can see, when we move, the effect fades out to the minimum alpha value, and when we stop moving, the effect comes back. And it's customizable through the parameters in editor. So now let's move on to the next part. The next part being pulsing between two gradients. This should be really easy to do. On C# side we simply duplicate the gradient and path variables and call the generate texture function the second time with those variables. Now on the shader side we again declare the second or alternative gradient texture, and then we sample it alongside the main one. And we interpolate between the two colors based on some function of time. In this case, it's a cosine function. So let's see how it looks. But before we do that, of course, let's assign generate and assign the new texture to our material, and let us look. And looks like it works exactly as intended. As you can see, the effect pulsates between the two gradients. We can customize those gradients completely. It doesn't have to be the same two, just with different opacity. It can be two absolutely different gradients. And with that, this point is as well done. Now with the minor tweaks, I had exactly one thing in mind. So if we set the minimum alpha for the fade out to 1, which would make it so that we don't fade out at all, and we move around and see what's up, we can see that the skybox just looks weird at times, especially if we move a lot. Yeah, I really don't like how that looks. And I wondered if removing the skybox and replacing it with a solid color would make a difference. So let's do just that. Let's go to lighting, environment, set this to none, and then select both of our cameras. And in the environment background type we said solid color, and let's make it blue. And let's see if this changed anything. Yes, looks like it did, and yes, that's exactly what I wanted to see. Now the background doesn't matter at all. Now we can only focus on the environment, and that is pretty good. Alright, so with that the minor tweaks are also done, and we can move on to the project overview and the showcase. Now, project overview, or rather a final implementation overview. This is of course simplified, but yeah, let's go through it. Let's go first through the editor time part. This only happens once during the setup. What happens is we have two gradients, G1 and G2, which we bake into the textures of gradients G1 and G2, which go into our shader. Now, on runtime, while we're playing the game, what happens is we get the texture or get the frame rendered by our camera and put it into render texture 1, and then with a delay of X frames it goes into render texture 2. Both of those render textures then go into our shader on GPU, and what happens is we define delta, which is the difference between our two textures, the current one and the delayed one. So remember that we have this delta value. Then we have the G1 and G2 gradients or gradient textures, which with some function of time we interpolate between, getting G, which is the final gradient. Then we have the delta value, which we evaluate with some remapping. So remap and evaluate it against the gradient. So we sample the gradient using the delta value, and we get the final color, which we multiply by the alpha value, which comes from the camera movement, and that is our shader output. So this is the simplified overview of the effect. That's what we did over the last 4 videos. And yeah, this is pretty much all I have to say about the motion extraction effect. Now, of course, there are other things that I could have done. I still haven't done the customization UI because I just don't want to spend too much more time on this effect. As cool as it is, I would like to focus on other stuff. Now, of course, if there will be demand in the comments below for me to do something else, I will do that. I will listen to my dear viewers, but generally I think it's time for me to move on to other projects. With that, I will just go on to the showcase part. There will not be any commentary in the showcase part. So, thank you for watching, have a great day, and enjoy this showcase of the motion extraction effect in the Unity engine. Thank you.